All right, so lesson 5.1 is about radicals. So the objective is that you can simplify a radical with a coefficient of 1 and combine like radicals to simplify an expression. That sounds really like complicated and crazy and hard. It's not as bad as that sounds, okay? We'll go through some examples and you'll see what those all mean. So first we have to talk about what a radical is. A radical is
You're
anything.
not presenting.
Thanks. Appreciate you. I appreciate that. Thank you for not letting me get super far. Okay. Can you see it now?
Yes.
Beautiful. Thank you. Okay. So a radical is anything with a symbol like this. There's a lot of different ones. It could be, here's examples of radicals. Square root, which we know. We use that a lot. There's also a cube root where there's a 3 on the end of it. There's a 4th root. You can do any number there, okay? Those are all radicals, anything with that root symbol. Things that aren't radicals are like 16, 5, -4, -1/2. Like anything without a square root or a root is not a radical, okay? So what we're going to try to do is take these things and make them look nicer. It seems kind of silly, but when you're in Algebra 2, you're going to need to do a lot of work with radicals. So we want to start practicing now, okay? Before we start, there's some numbers that you guys need to become familiar with, and they are called perfect squares. Perfect squares are numbers that come from something times itself. For example, what is 5 times 5, you guys? 5 times 5.
25.
Yep. So this 25 comes from 5 squared, or 5 times 5. What's 4 times 4?
16.
16. So that this one comes from 4 squared. 3 times 3 is 9. 2 squared is 4. Whoops. 1 squared is 1. 6 squared, 7 squared, 8 squared, 9 squared. What would be next in this list?
$100?
It would, yes. Did you do 10 times 10?
Yeah.
Perfect. So you guys could come up with this list of perfect squares. It's not just like a randomly memorized list of numbers. It's literally just 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16, and so on and so on and so on. So you could continue this list. These are going to be some of the ones that we use quite a bit. And when I say use quite a bit, here's what I mean. So I have a picture here that I took. I'm going to look on my phone, and we're going to color code, okay? So when we simplify radicals, there's about 4 steps the way I see it. So I try to really break it down so that you have everything as clear as possible. So the first step is to divide, in this case, 50, because that's what's right here, by numbers in the list until it's pretty. And here's what I mean. Okay. Can you guys pick a number in that list that is close to 50 but isn't more than 50?
$49.
Perfect. Let's try it. We'll start with 49. So what the first step says is divide 50 by the numbers in the list until it's pretty. Okay, so what that means, 50 divided by 49, that is not pretty. It's got a decimal. So what I'm saying is we want integers, which are just pretty numbers. So 49 doesn't work. The next number in the list is what? If we go down. What's after 49?
36.
Yep, 36. I always say these are garbage, so this turns out like garbage. The next number in the list,
25.
okay? Ooh, that's pretty. So that's what I mean. That's pretty. What that means is 50 is the same as 25 times 2. Does that make sense? 25 times 2 is 50.
Yes.
Okay. So that once we get that pretty number, we're good. So the second step then is to rewrite 50 with multiplication. So instead of 50, I'm going to write that as 25 times 2. Do you agree that 25 times 2 is still the same as 50?
Yes.
Okay, so I'll show it. I'll prove it to you. So I'm going to take the square root of 50, hit enter. We get some janky number, okay? Then I'm going to do the square root of 25 times 2. We still get that janky number, okay? So I've just changed it to look a little bit different. Step 3 is to separate. The reason we do this is we're looking for one of these two numbers must be in this list. It has to be. That's the whole purpose of having that list of numbers. So what we're going to do then is we're going to split this into the square root of two things. Square root of 25 times the square root of 2. So I'm going to go square root of 25. I'm going to go outside that times square root of 2. Still have that same weird number. Okay, so we're still good. And here's the last step. So I'm really breaking this down for you guys just so that you don't possibly miss anything. The fourth step is to simplify. So what is the square root of 25? Do you guys know? The square root of 25 means what number times itself is 25.
Five.
Yeah,
5.
exactly. And you see how that's like right here? So this is 5 square root 2. So when we put this in the calculator, 5 times the square root of 2, we still get that. You can also type it in like this, 5 times square root 2, and just have them touching, and it is the same thing. So this is what we're doing today. We're just breaking it down. We got to find what it multiplies by, split it up, and then simplify it, okay? So we're going to try a few more. You guys cool with that? Here's what I would ask. Either take a picture of this, like this chunk right here, or write it down. Is anybody still writing?
Yeah, me.
Okay. And then remember, you guys, I also put completed notes in the Chapter 5 module. So it'll say Chapter 5 notes. Below that, it'll say Chapter 5 notes completed. And then it's going to say 5.1. Will you just let me know when you're done writing? No rush.
Done.
Beautiful. All right. So, okay, I think I'm going to skip this right now. I don't want to deal with that and confuse anyone. In school, it would be a little easier to explain this and do a little more exploration. But for right now, I just want us to practice a little bit more. Okay. So first thing, if you guys can write this on your paper, here's what I want you to write. I want you to write 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. We should be able to stop at 100. So list that set of numbers. Those are perfect squares. I'm going to add 2 more just because of one of the numbers on here. Okay, so if we follow our steps, okay, you guys are trying to simplify these. Square root of 48, if we check it, is trash. So what we're going to want to do is simplify it. Okay, so we got to go through the process. So if you look at the steps that you either wrote down or you took a picture of, the first step says divide the number, so in this case 48, by numbers in the list until it's pretty. Okay, so on your paper, I want you to write this one, square root 48. Just write that. And then I'm going to have you do these for this example so you have a couple to run off of. Okay. So in this list of numbers, what is close to 48 but not bigger than 48?
24. Oh, no, never mind. 36.
36, yep. So first thing we would do is we would try 48 divided by 36. So I want you guys to write that down. That comes out as trash. That's garbage. So I'm just going to put a sad face. I don't really care what it is. It just didn't turn out well. What are we going to try next?
25.
Yep. You guys probably already know that's not going to work because 48 doesn't end in 5 or 0. There it is. No good. All right. What comes next?
16.
Oopsie. So that one works. So if we do 48 divided by 16, it equals 3. So in our notes, the second step that we did was we rewrote it. Okay, so what we're going to do is rewrite it as this times that. I usually put the number from the list first. You don't have to, but I usually do that. The next step is to separate them. So write them in 2 separate ones. Square root 16, square root 3. And what is the square root of 16? That means what number times itself is 16?
4.
Mm-hmm. And you guys, you can count in the list. It's 1, 2, 3, the 4th number. So that means it's 4. So we're going to have 4 root 3, and that is our final answer. You can always double check. If you do second square root 48, hit enter. And then if you try 4 square root 3, we got the same thing, so we're good. Okay. How about we try 24 now? Let's try this one right here. So write that one on your paper. Okay. What number is closest to 24 but not bigger than 24?
16.
Okay. So we're going to go 24 divided by 16. No good. You don't need to write all these out when you're doing your work. It's just I'm doing it so that when you look back at your notes, you know what we did. All right, what comes next? That one didn't work. What should we try next?
9.
9. Ugh, no good. And then next,
4.
4. Good. So here's the thing, you guys. You'll start to notice, oh, you'll be like, ooh, this number is divisible by that. But we have to find the biggest one. So you really do want to check all the way down the list, okay? Because sometimes a bigger one might surprise you. So 24 divided by 4 works because it comes out as 6. So what we're going to do is step 2. We're going to rewrite 24 as 4 times 6. Then we're going to separate them. Square root 4 times square root 6. And what is the square root of 4?
2.
2. Again, this is the second number in the list, so that means it is 2. Square root 6. And then we can check square root 24 is this. Square root, oopsie, 2 square root 6. Same thing, so we're good. Do you guys want to try this one by yourself really quick? Can I just have you try? I want you to try this one. We'll do it together in just a moment. Okay, so first question, I know you're not probably done, but what did you start testing? Which number did you start testing? What number did you divide by first to try?
64.
Yep. Okay. So 72 divided by 64, no good. What would come next?
49.
Yep. Also no good. What's next?
36.
Okay. All right, this works. So what do we do now?
Square root.
Mm-hmm.
Oh,
You were right. Go ahead. Square root what?
square root 36
And then
times 2.
got it. Perfect. Then let's split them up. Root 36, root 2. And what is the square root of 36, you guys?
6.
Got it. Because it's 1, 2, 3, 4, 5, 6th in the list. So 6 root 2. Let's see. Enter. And then we'll try 6 square root 2. Enter. Same thing, and we're good. Okay. There's a trick you guys will notice, but I'm not going to tell you because I don't want to confuse you. But you don't necessarily have to test all the numbers. But I'm not going to tell you, so I don't want to confuse you. So we'll do this.
Question.
Yeah, go ahead.
What do you do if the number is bigger than 2? Like you said 36 times 2, but when you square root 36 times 36 times 36, right?
Say it one more time. 36 means 6 times
Is
6.
square root, is it the same thing as 36 times 36?
Oh, good question. It's actually the exact opposite. So square root 36 is this. You're thinking 36 squared. That's what 36 times 36 is, which is big. So 36 squared is 36 times 36. You want to do the square root, which makes it smaller. You're looking for the roots, like the roots of a tree are small. So you're looking for the smaller number. Does that answer your question?
Yeah, but I don't know. I think I've been using that method. I don't know why.
You think you've been using this squared? Okay. I wonder if you're thinking 36 times 2 instead of 36 times 36. Maybe you're thinking 36 plus 36?
No, I use like 36 times 36.
Oh, okay. Yeah, so something's goofy then. Those are going to end up not correct. You want to just use this and put that straight up into there. So let's try this one and then tell me where you would do. You tell me as soon as I get to the point on this one, let me know when you start to do that, like it times itself thing, okay? So here in the list, closest to 147 without going over is 121. So we're going to go 147 divided by 121. That doesn't work. 100 will not work. Divided by 81. Nope. 64. $49. Okay, there it is. So 147 divided by 49 equals 3. So what we're going to do is, instead of writing 147, we're going to rewrite it as 49 times 3. And then we split this up to root 49, root 3. Now this is where you have to ask, what number times itself equals 49? And if we count in the list, it's 1, 2, 3, 4, 5, 6, 7th number in the list. So that means it's 7. You can check. There. And then 7 second. We get the same thing there. So to highlight, because I have multiple things circled, these would be your final answers. You guys okay with those? Let's do scale of scale of 0 to 2. 0, no clue. 1, I am starting to understand. Can you guys take a quick minute to answer that? So my question is, it's in the upper right of your screen. I want to know where you guys are at. So 0 means I have no clue what you're talking about. 1, I'm starting to understand. And 2, like, yeah, I'm cool, I got it. Okay, keep answering. We got a couple more, okay? So I'm hoping that once we do these couple more that you'll feel like better about it, okay? So here, this one's actually kind of nice. So square root of 100, what is the square root of 100?
10.
Yeah. I'm just going to list these again really quick. Okay, 100 is in the list, so that means we don't have to do all that work. This is just 10. Square root of 100 is 10. All right, so square root of 32, let's follow our steps. First thing we do is divide by numbers close to 32, but not over. So what number is that going to be? Can you guys throw it in the chat? I want to see if you guys can answer that in the chat. So which number do we try dividing by first? Yes, thank you, Lance. It is 25. So we're going to start with 32 divided by 25. No good. What's going to come next? You guys can...
16.
Good. Divided by 16. Okay, that one works. So 32 divided by 16 is 2. Whoops. So we're going to take that and we're going to rewrite it. 32 is going to become 16 times 2 because, again, that's the same. Whoa. That's the same thing as 32. And then we split it up. This number is in the list. So what is the square root of 16?
4.
Yep. Times the square root of 2. There's that one. All right. Let's do this square root 8. So what number is close to 8 in the list, but not over 8?
4.
8 divided by 4. What's 8 divided by 4?
2.
Yep. So we can take this and rewrite it as 4 times 2. Split it up. What's the square root of 4?
2.
So we get 2 root 2. Okay, 300 is really big to test. But which of these numbers up here is a clear multiple? Which one do we see we can definitely divide by?
100.
Yeah, so let's just change this 300 into 100 times 3. Are you guys okay with that? Otherwise,
Yeah.
you would just have to test like a bunch of numbers and it's doing a lot. So square root 100 times square root 3. What is the square root of 100?
10.
Up. And so this is going to become 10 square root 3. Okay, so that's the first chunk. There's going to be a couple questions like that on your quiz. I'll show you how they look. And then down here, this is the last part, and this actually goes pretty quick. So combining like terms is putting things together that look the same. So here's what I mean. This 4x and this 6x. Notice I circle the sign in front because that tells me if it's positive or negative. Those look the same because they both have x's. So that means there are 10 x's. Similar move, I can put these together because they both have y's. Negative 3. Here's the negative key. Negative 3 plus 7 is 4. So we have plus 4y. This would be what combining like terms does. So here, this 5x and this 2x, that's 7x. and we have a y minus 4y. So if we do 1y, that's what this means. It means there's one of them. Minus 4 is negative 3y. So down here, same thing. It just looks different because they're square roots instead of letters, but they're still kind of just ugly unknown things. So we have this root 3 and this root 3. 6 minus 4. 6 minus 4 is 2 root 3. And then this is like 1 plus 7 is 8. So we have 8 root 5s. So over here, we have a 15 root 5. Do we have another root 5? What's something else that looks the same?
5, 5. I don't know.
Which one? How about this one? You see how that has the root 5? What I'm talking about is like this part right here. Looks the same. Is there another one?
The last one?
The last one, yep. And that's a plus, so we want to circle the sign in front. So on our calculator, we can do 15 minus 5 plus 2, and we get 12 root 5s, because they all are root 5. And then here we have this one and this one. So we have negative 11 plus 12 is 1. So we have plus. You could put a 1 here if you want, but usually math people don't. They'll just do that. Okay? So it's really just combining stuff that looks the same. I'm going to stop recording really quick, but then I'll show you your quiz.